Hello everyone. In this lesson, we will discuss increasing and decreasing functions. We will also discuss maximum and minimum of functions. Let's first talk about increasing and decreasing functions, particularly increasing and decreasing of functions on an interval. Mathematically, we say that f of x is increasing on the interval AB, and AB is an open interval, if f of x sub 2 is greater than f of x sub 1 when b is greater than x sub 2, is greater than x sub 1, is greater than a. So that means a, or the interval AB, A is your lower end, B is your higher end of the open interval. There are two x values, x sub 1 and x sub 2, on that open interval. Notice that the interval A and B are x values. They're not x and y values. They're just x values, where A is the lower value in the interval and B is the higher value in the interval. Now, corresponding to these, to x sub 1 will be f of x sub 1, the function value, and the function value at x sub 2 will be f of x sub 2. Now, if when x sub 2 is bigger than x sub 1, f of x sub 2 is greater than f of x sub 1, then the function is increasing in that interval AB, as seen by this diagram here. Next, we say f of x is decreasing on the interval AB. It's an open interval AB. If f of x sub 2 is less than f of x sub 1, when b is bigger than x sub 2, is bigger than x sub 1, is bigger than a. In this diagram, we have the interval AB, where x sub 1 is less than x sub 2. F of x sub 1 is bigger than f of x sub 2 when x sub 2 is bigger than x sub 1. So in this case, we have a decreasing function. We say f of x is constant on the interval AB if f of x sub 2 is equal to f of x sub 1 when b is greater than a, and x sub 2 less than or equal to x sub 1. Okay? So it really doesn't matter which one is to the left or right in terms of x sub 2 and x sub 1, as long as f of x sub 1 is equal to f of x sub 2, we say we have a constant function, or f of x is constant on that interval. Okay, let's look at an example. This example says a car's position is shown in the diagram. What did the car do? Notice between 1 and 4, we have an upward sloping line from left to right. Between 4 and 5, it is a curve, but it's still upward sloping. Between 5 and 6, it starts going down in a curve, and between 6 and 8, it is flat. So what did the car do? From, let us say we labeled our diagram T and P at P of T, right? It's labeled in terms of X and Y axis, T and P of T, which is the position of the car at time T. When T is equal to 0 to T equals to 5, the position of the car was increasing, right? And from t is equal to 5 to t equals 6, what is happening? The position of the car was decreasing. And from t is equal to 6 to t equals 8, the position of the car was constant. So again, it's increasing, moving from left to right, we're going up. It's decreasing, going from left to right, we're going down. And it's constant, it's going from left to right, we're just flat. Okay, or the graph is flat. Right, and that's it for increasing, decreasing. So what we are looking at is specifically the x values, and if we want to use colors to say, okay, from t equals 0 to t equals 5, we could use color, let's see, red color to represent that we're increasing. And if we wanted to say, okay, between t equals 5 to t equals 6, we could say we use a different color. Let's say orange, that's decreasing. And between t equals 6 to t equals 8, we could use, let's say, a different color to say, okay, that is constant. Green to represent constant. Here, what we're doing is that we're just highlighting different sections of the domain to see what is happening in these these intervals. Okay, and so that's what we're concerned about with intervals. We're talking about intervals along the x-axis. All right, now let us talk about minimum and maximum of function, or relative minimum and relative maximum. Now, by definition, f of a is a relative maximum if f of a is greater than or equal to f of x for all x in an open interval of f of x, right? So a maximum means that if we picked, let's say, an x value of a, and if we found a point a, f of a, it means that f of a is the highest point within a particular open interval. So within any open interval, let's use parentheses, around a, f of a will be at the highest point. Okay, so that's a maximum. Or it's greater than all the other f of x values around that point, as can be seen by this diagram. Another way of saying relative maximum is to say local maximum. We can call it a local maximum. That means within that interval around that point, that function value is the highest or the tallest. Next, we talk about a relative minimum. If f of a is a relative minimum, if f of a is less than or equal to f of x for all x in an open interval of f of x. So in an interval around where the x equals a, your f of a value, that's the point a, f of a, your f of a value will be less than or equal to all other f of x values. All the f of x values are along this curve. So within this interval, this point is the lowest point. So all the other f of x values are higher. Let's say that. Then we have a relative minimum. Then f of a, so you're talking about the function value being the minimum value, right? Not the a value, but the function value is the minimum value. So you will say f of a is the minimum, right? In this case, a relative minimum, or in other words, we can call it a local minimum, which is within that little region around where x is equal to a, your f of a value is the lowest point of all the other f of x values. Okay? Now, one important thing to note is that if f of a is constant in an open interval, then it is both a relative minimum and a relative maximum. Right? So if a constant f of a value in a particular interval, then it's both a max and a min, right? And that is about it for the theorem. Let's look at an example. Now, given a graph, many times you will be given a graph to say, okay, find the relative maximum, find the relative minimum based on this graph, right? So here we have a graph that shows an upward sloping line between -3 and -2, x equals -3 and -2 on the interval. And then we have a parabola between x equals 0 and x equals 4, and then a downward sloping line from x equals 4 to x equals 6. Now we want to find a relative maximum. A relative maximum. A relative maximum would be the f of a value exists. The f of a value exists, and it is also the highest point between a particular interval. So if we're looking at where x is -2, we see a high point there at y is equal to 5, but that is not a maximum because that point is in an open circle, so it does not exist. The same thing happens where at x equals 0, it's an open circle, so the point does not exist. Again, where x equals 4, there is an f of x value or y value at y equals 4, but again, because it's an open circle, it does not exist. So for relative maximum, we shall say there is none. What about relative minimum? Well, there's an open circle where x equals -3 and y is equal to 2, but because the open circle does not exist, so that is not allowed. When x is equal to 2, there is a minimum when y is equal to 0. So there's a minimum where f of x is equal to 0, and that is when x equals 2. When x equals 2, the domain of this function is goes from the x values -3 to -2, and then we're going to union 0 to 6. 0 to 6. That's the domain of that function. The range will go from 0 including, so the range is including 0, so we use brackets there, 0 to 4, and 4 is not included, so we use a parentheses. The interval on which the function is increasing will be from -3 to -2. And notice we're just using x values here, and then we will union 2 to 4. 2 to 4. Notice that we will always use parentheses for intervals where we're increasing or decreasing as well. Always use parentheses. Interval on which it is decreasing will be from 0 to 2, and again from 4 to 6. We use a union right there, 0 to 2, union 4 to 6. And the interval in which the function is constant, there is no interval on which that is constant. So again, we have found our minimum, which is 0. There's only one minimum because everywhere else is a closed circle. Also, we need to know that for something to be relative, it must have f of x values on both sides, not just on one side. For it to be a relative maximum or a minimum, good point to note is that it must have f of x values on both sides. Thank you for tuning in. Please remember to subscribe, and see you next lesson.